the argument is in our case actually this A, because we want to make the gradient from smaller flowers which has the amplitude 0 to larger flowers with a maximum in 1. So the variable we need instead of x is this one. So this is why the domain of our function is between 0 and 1. X is between 0 and 1, and our conditions are: in the middle of the flower we want that R to be 40, so first condition is R of 0 is 40 and the R of 1 is 230. I'll call this value R1 and the other R2. First we find out that B1 is R1, and from the second condition we find out that A1 is the difference between R2 and R1. So this is how we obtained first interpolation. I'll also define our parameters. So now we have to replace color values with another parameters like R, G and B, and those three are our first degree function. And I also will change the argument with our, and we'll do the same for G and B. Okay, and we obtained the gradient between the two colors I chose. So now we can also prove, if we want, the formula of interpolation, which is studied in university, and we'll see it's very similar with the one we have here. I'll rearrange the variables, so I'll give the common factor R1, and this is what we obtained. I'll also copy the second formula, and we obtained the same result in a different way. So next step is to modify the function, the linear function, with a different function. What we should take into account is that the function we choose has also to have the domain in 0, 1 and also the image in 0, 1. I will define a C variable, and this one I make sure on the 0, 1 domain its image is also 0, 1. I write the expression of the function here, and then I replace A with C. Okay, it looks great. I'd like to make this image a little larger. So those numbers are the dimension of the window. Those two numbers means the center actually of the coordinate system, and this one is the dimension of the flower.